Okay, today we are going to be looking at learning target 15. I can verify similarity through a sequence of transformations, including dilations. And we're going to be looking primarily at how do we verify similarity. We have talked about this over the last couple of lessons, but we're just going to formalize the process today. So, to verify similarity, if you have two polygons that are similar, then the fact that we know is true is that their corresponding angles are congruent and the measures of their corresponding sides are proportional, meaning if I set up multiple ratios, the ratios all simplify to the same value. So if we look at our example here, we have our original ABC, triangle ABC, and our dilation, triangle XYZ. So based off of the markings within the triangles, I can see that angle A is congruent to angle X because they both have a single arc. Angle B is congruent to angle Y, and angle C is congruent to angle Z. So that fits the first criteria that I need my similar polygons to have. All of the angles are congruent. Or as we remember from our angle-angle similarity, if we're looking at a triangle, at least two angles need to be congruent, but we know that that means the third angle will also be congruent. Our second criteria is the measures of their corresponding sides are proportional. And so in order to double check that, we're going to set up our scale factor ratios of the dilated value over the original. So here I don't have any side values, but I would take, if I were measuring or if I was given, I would take maybe the side length of XY and set that up in a ratio with the corresponding side AB. And then whatever the values are, so then I'm going to say YZ, that's my second side. YZ corresponds to BC, and then XZ corresponds to AC. And if all of those sides have the same, are all equal, they all have the same ratio, then I know that my side lengths are proportional and I meet that second criteria point. So if the angles are congruent and the sides are proportional, then yes, my polygons are similar. So in this situation, if all the statements are true, then the figures are similar, and we would write our similarity statement, which we had discussed earlier. If I say that triangle ABC, and we would use the similar symbol, it's going to be similar to, and I need to be sure that as I name the second triangle, that I use the corresponding parts of the triangle in the correct spot. So since angle A is congruent to angle X, I'm going to start my triangle with the letter X. B is congruent to angle Y, and then C is congruent to angle Z. So then I know that I've named my corresponding triangle or my similar triangle appropriately. So let's see what this looks like. So we want to first graph our original figure and the dilated figure and then verify that the dilation is a similarity transformation. So right now I want you to pause the video and I want you to go ahead and put these um, or graph these images. So graph the pre-image and graph the image if it helps. Do them in two different colors and then we will start back up once you have those graphed. So now that you have your pre-image and image graphed, you can see my pre-image is significantly larger than the image. So if this is a similarity transformation, it's definitely a reduction because our pre-image is larger than the second image. The only angles that, when we look at the angles, the only angles that we can really for sure say would be angle A and angle D. Those are right angles, so we know for sure that they are congruent. We don't know without using tracing paper or a protractor whether or not angle B and angle C have congruent angles. However, for the sake of this problem, I'm just letting you know that angle B is congruent to angle E and angle C is congruent to angle F. So if we look at the sides to verify whether or not the sides are proportional, I know that I'm going to take my dilated, so we'll say that DE That compares and corresponds to AB. And then we have DF, which corresponds to AC. And then we have EF, which corresponds to BC. So when I'm setting up these proportions, I'm just going to use the side lengths that I'm able to count right off the bat, and that's usually a good place to start. So from D to E, that's going to be 2.5. So I'm just going to rewrite these underneath here. So we have 2.5 over AB, which is 1, 2, 3, 4, 5. And then we have DF, which is 4. Length is 4. 1, 2, 3, 4. Over AC, which is 8. And then EF and BC, if you recall from our previous learning targets, to find the distance between 2 points, we do need to use the Pythagorean theorem. So if I'm starting with EF, I can take 2.5 squared, remember leg squared, plus leg squared equals your hypotenuse squared. Okay, and 2.25, or I'm sorry, 2.5 squared, you have 6.25 plus 16 equals h squared. So you have 22.25 equals h squared. And then hopefully you recall, in order to undo a square root, we do have to take the square root. Or I'm sorry, to undo a square, we have to take the square root. Now, here's the nice thing, is we don't have to type that really into our calculator later, other than just leaving it as the square root of 22.25. Because everything from there we're going to be using calculator work, and so we don't need a decimal, and rounding it will sometimes lead to a wrong answer. So we don't want to do that. So if I look at my second triangle, my pre-image, so I have A is 5, so 5 squared plus 8 squared equals h squared. And then we have 25 plus 64 equals h squared, which would then leave us with 89 equals h squared. So if I take my square root of that, again, I don't need to get my actual answer. I can leave it in radical form, which would just be the square root of 89. Now here's where we just have to grab that calculator and do our last minute check. We want to verify, is 2.5 divided by 5 the same as 4 divided by 8, the same as the square root of 22.25 divided by the square root of 89? So if you type that into your calculator, and again, I'm not expecting any of this to be done mentally. It's awesome if you can do it that way, but it's not required. 2.25 divided by 5, that simplifies to half. 4 divided by 8 simplifies to half. Square root of 22.25 divided by the square root of 89 also simplifies to a half. Since all of those are true, we can verify that yes, these triangles are similar because their angles are congruent as well as their corresponding sides are proportional. So to write my similarity statement, I'm going to say triangle ABC is similar to triangle A is congruent to D, B is congruent to E, and C is congruent to F. And if you're really kind of excited about proportionality, you can even say that it's similar, and it's obviously a dilation with a scale factor of half. 1 over 2, right? We said at the beginning it was a reduction, therefore we know that it's going to have a scale factor that's less than 1. That's not necessarily required for these lessons or these examples, but again, it's good to keep your mind kind of seeing how it all ties together. All right, let's look at our next example. It says determine if the two figures are similar by using transformations. Explain your reasoning. All right, so here I see I have two triangles. I have one angle, I have a right angle, so I can see right off the bat that angle Y and angle O are congruent. Woohoo! All right, but my other two angles, darn, they're not the same number, but they're also not corresponding. So I have to use my triangle sum theorem that we learned a couple days ago to identify the missing angles. So if I look at my first triangle, AYP, I see that I have 90, I already have 20, and then I have a missing angle. I know that that should all equal 180 degrees. Okay, so if I have 90 plus 20, that gives me 110 plus x equals 180. Subtract 110, x equals 70 degrees. So angle P is actually going to be 70 degrees. All right, that doesn't seem to match angle x, so I'm just going to do some additional practice to make sure that I am on the right track because I want to make sure that I don't do anything wrong. All right, so I see 90 plus 80, and that's going to be 170 plus x equals 180. So that would mean x is equal to 10 degrees. That's definitely not congruent. So while angle A and angle B are in similar locations, corresponding locations, they are not congruent. All right, and if I go to my other angle, angle P, and angle X, they're in corresponding positions, but yeah, they are not congruent. I already did my math there, so I know they're not congruent. At that point, because with our angle-angle similarity, we know these are not going to be similar. So I don't even have to do my side length and my proportionalities. If I wanted to, I could. And for the sake of just showing you what it would look like, I do want it to kind of give you that idea. So let's see if I had, we'll say 20 BO is compared to or corresponding to AY, which is 8. And then if I had 25 compared to 10, well, 20 divided by 8 is going to be 2.5. And then 25 divided by 10, oh, hey, that's 2.5. That would be really tricky, right? That kind of makes me think, man, if I knew that third side, maybe they could be. But again, because the angles do not have at least two, the angles are not all congruent, there, this is not going to be um, similar. Okay, so I want you to write out what you would say to explain why these are not similar. I'm going to pause the video and then I'm going to have restart it and you can compare what you wrote. Okay, so you can compare your response to my response, add some things into yours if you feel that you need to. But the biggest point that you need to include is that you do not have two angles that are similar, or I'm sorry, that are congruent. And remember, because of angle-angle similarity, we need to have at least two angles that are congruent, and this one did not. Therefore, it is not similar. All right, let's look at our last example here. We want to determine whether each pair of polygons is similar, then verify that the dilation is a similarity transformation. All right, so I want you to pause your video at this point, and I'm going to pause my video at this point, and I want you to try this one on your own. Okay, and I want you to see how you do. I think sometimes, we don't know what we don't know until we try it. So go ahead and try this on your own, and we will compare answers in just a moment. Okay, so go ahead and compare how you did. Um, you would have used your angle sum theorem to identify the congruent angles, which this did have all three angles are congruent. Angle C was congruent to angle E, A was congruent to O, T was congruent to R. So then when we set up our ratios for our side lengths, we had RO corresponded with AT, OE corresponded with AC, and RE corresponded with TC. And so when we went ahead and plugged the numbers in or the side values in for each of those segments and then divided, we could see very clearly that those side lengths had three different ratios. And therefore, those two triangles, triangle CAT, is not similar to triangle EOR. And so the description that I put for myself is that these triangles are not similar because their sides are not proportional. So even though the angles were congruent, and we know angle-angle similarity, if their sides are not proportional, it does not does not work. Okay, that's the end of our notes. Go ahead and start working on your homework. Bye.